So in this section, I just need to know x equals r cosine theta, y equals r sine theta. Now when you square and add, you will see x squared plus y squared equals r squared cosine squared theta plus r squared sine squared theta. And then if you factor out r squared cosine squared theta plus sine squared theta will be 1. And then if you take the square root on both sides, then you get r equals square root of x squared plus y squared. And this is the relation between Cartesian and polar. And the angle theta is tan inverse y over x. If you look at the picture on the right side, everything will be clear. For example, when I'm saying my point is xy, so I know this length is x and that one is y. So if you consider this one as a right triangle, these are legs. So with respect to the reference angle theta, y is opposite and x is the adjacent. So we know tan theta is opposite over adjacent. And that's why theta is tan inverse y over x. This is simple, you know already. Okay, now I'm taking one example. There are many representations of polar and Cartesian. So I'm using one example, say that my r is positive, non-negative you can say, greater than or equal to 0. And theta will be between 0 to 2 pi. And we can say that could be 0 but less than 2 pi, because when you say 2 pi equal, then it is same as 0. That's why we put it 0 to 2 pi. 2 pi is not inclusive. Cartesian form (8, 0). Now you need to write this one to r theta form. Okay, so this will go to polar coordinate. So in this case, we have x equals 8, y equals 0. So we need to find r and theta. So r will be square root of x squared plus y squared, which is 8 squared plus 0 squared, so you get 8. And then theta will be r tan or tan inverse y over x. Tan inverse 0 is 0. The point is here. 8, 0. So this is your x, which is also r. And the angle is theta is 0. So in this example, your Cartesian and polar looks very similar, same, but they are having different measurements. Okay, I'm taking you to the next example. Say that you have another one. The point, say I'm giving you -6, +6, and we want to get r theta form. So then our r will be square root of -6 squared, 6 squared, which is 36 plus 36, that will give you 6 radical 2. And theta will be tan inverse 6 over -6. You get tan inverse -1. So usually we know tan inverse -1 is negative tan inverse 1, which is negative pi over 4. But if you see the restriction here, we want to get positive angle for that one. So the positive angle for that one will be, now let me go with the picture, -6, 6. So -6 will be here, +6 will be here. So then the point is here and you are looking for this angle, not there. Okay, so we have this point. So how do I get this here? You have learned this one in pre-calculus, that if you have this one here is negative pi by 4, so then this one will be just pi minus pi by 4, which is 3 pi by 4. So that my theta positive, if we consider, it will be 3 pi by 4. So then we got our point -6, +6, which is the Cartesian, goes to polar as 6 radical 2 and then 3 pi by 4. So then you get the same location. Now this is your length r from here to here, which is 6 radical 2, and the angle here is 3 pi by 4. I hope it makes sense to you. We have, say, 7 and then 3 pi by 2. This one we want to convert into xy Cartesian form. So then you can see that your r is 7 and theta is 3 pi by 2. Now we have one relation, see, x equals r cosine theta. So r theta known, you find x. R cosine theta, 7 cosine 3 pi by 2. Now if you look at the value of cosine 3 pi by 2 from unit circle or your own understanding, you have that one is 0. So that gives you 0 for x. Y will be r sine theta, 7 sine 3 pi by 2. So 3 pi by 2 is actually here on this. This is the angle 3 pi by 2. And you know sine pi by 2 is 1 and 3 pi by 2 will be negative 1. So then that one is giving you 7 times negative 1, negative 7. So we get our coordinate, that one here, x is 0 and y is negative 7. So here we have, say, we are given negative 1 and then pi by 3. So now the restriction we had, r greater or equal to 0, is not valid here. That was only for question number 1, because you see here negative 1, this is another representation. So this representation has a meaning. So the meaning is like this one. When you say you have pi by 3, the angle is here, pi by 3, and the length of this line is at 1 unit, so it is here. But when you're coming on these, so this one you can consider now negative 1, and the angle is same as pi by 3 here. Okay, so this is different representation. So how we get our Cartesian? The same process, you say x equals r cosine theta, and you have r equals negative 1, theta is pi by 3. So we are getting negative 1 cosine pi over 3. You know that cosine pi over 3 is 1/2. So you get negative half. Y equals r sine theta, negative 1 sine pi by 3, which is 60 degree actually. So sine 60 is radical 3 over 2. So radical 3 over 2. And as I said, the point we have located here, isn't it, in the third quadrant. In the third quadrant, you can see x is negative, y is also negative.